Hello, everyone. I think we can start. So I'm Michael from LEVERTON, and thank you very much for giving me the opportunity to give a talk. And the title is my talk is AI at LEVERTON. The more data, the better the AI, isn't it? And in this talk, I want to talk a little bit, first of all, about LEVERTON, the company, because I guess most people of you don't know it. Then I want to show where we use AI. Then I want to go a little bit more into detail and tell about our optical character recognition system, about our information extraction, which is like the main artificial intelligence that we use. And at the end, also about the data, as my title states. And I want to show the challenges that we face because we have a lot of data issues, especially because we have data from different sources. So a few words about myself. So I'm leading the AI department at LEVERTON. And from my background, I'm a mathematician. I worked since about 10 years in the area of artificial intelligence. So first of all, a few words about LEVERTON. What do we offer? LEVERTON develops and applies deep learning technologies to automatically extract data from corporate and legal contracts. So in the past, especially at the very beginning of LEVERTON, we had our main focus on real estate contracts, which is maybe the most challenging legal documents you can have because they can be very big, very complicated. And now we also go into a little bit simpler document types. So normally you do it the other way around. You start with the simpler one and go to the harder ones. But we did it the other way around. And the whole process is not fully automatic. So normally our platform is used as a semi-automatic process where we have some review in place where everything the machine extracts will afterwards be corrected by human beings. And afterwards, the information is extracted from legal document. We keep the links to the section in the document where the information is coming from. So I think it's a little bit blurry, but what you can see here is like the viewer, which is our interface to our software. And here you can see specific data points, and you have a link to the part of the contract where this information is coming from. And this is very beneficial for a lot of companies. Because they can still see where is the information coming from and also check whether this information is still valid or is it out of date or something. And at the end, our customers can export the data to a target system. Our customers are many investors because in the past we worked a lot for real estate, on real estate contracts. And also many of our customers are big corporations which have many contracts, real estate contracts, but also a lot of leasing contracts, especially in the area of IFRS 16. This is a few information about our company. So at the moment, we have more than 100 customers who use our software. We support around information extraction from around 25 languages. But generally, the system is very simple. It's very simple to add new languages. It's just a question of data that we need to get a new language. For most of the languages, for some special languages like maybe Arabic, because it reads from right to left, a few more changes would have been necessary. We have 100% data transparency, meaning that every information we extract, we keep the link to where it's coming from. Our company was founded in Berlin around 7 years ago, and now we also have sales offices in London and New York, but the main development is in the Berlin office. We use more than 5 years of deep learning technologies, and we also have high data security standards because it's very important, because we deal with very crucial documents. Okay, so let's focus a bit more on what we do and where the AI comes into place. So what I learned at LEVERTON was that many companies have many contracts and they do not know what's exactly written in the contracts. So they have a lot of documents, they are still in paper, and they want to extract the information out of it. And up to now, this is a manual process. So people reading the contracts manually and typing the information into an Excel sheet. And this is inefficient. It's not transparent because they just type in the information, and at the end, you do not know where the information is coming from. And it's also error prone. And LEVERTON tries now to automate this whole process and to facilitate this process. So because it's inefficient, we try to deal this with using AI in order to automatically classify the document and extract the information. We keep the links to the position in the document, so it's transparent where the information is coming from. And we use a two-step review process such that every information is afterwards reviewed by 2 more people. It can be up to 2, can also be less. And this also reduces the error rate. AI means artificial intelligence. Oh, yeah. So where is AI present at LEVERTON? So whenever you upload a document, which is in most cases still a real paper, which is scanned, you need to do an optical character information recognition to get the word and the layout information out of the document. Layout information means especially what kind of information belongs together and what is the reading order through the document. This is a very crucial step for the information extraction afterwards. Then users can start the extraction. The first thing that's going to be triggered is the document classification, where you get which type the document is. So, for example, in the real estate context, you may have the lease amendments, invoices, handover protocols, and so on. And they contain different kind of information, and also some of them are legally binding and some not. So the information of the document classification is valuable by itself, but it also gives the feedback for the next step, the information extraction, what information can be expected. And afterwards, a two-step information extraction process will be triggered. The first one gets candidates for each data point, and afterwards those candidates are filtered. So the filtering step may remove some data points that have been found. I will show into more detail later why this is necessary. After that, everything the machine found will be reviewed by a human being. And after the review, we assume that all the data points have been annotated correctly, and we use the new documents for retraining our AI and getting better by this with more and more documents.
Can somebody choose the separate documents if you have one staple and you need only 2? Can you get in system the name of the documents that only this document can be read, or will it be read the whole stable?
It will read all the documents. Normally it assumes that everyone is legally binding, but you can exclude some documents if you don't want that. So let's get more into detail about the 2 steps, about the optical character recognition and the information extraction. So what is optical character recognition? The goal is to convert an image with text, which is normally like a scanned document, and you want to transform this into a searchable text. So for example, here you have this very bad scan of a recept, which is an image, so you just have the black and white pixel information, and you want to get the text out of it such that it's searchable. So here you can also see, since it's a low quality, you have many mistakes here in the result. Probably the most asked question I get about my job is, why do you have your own optical character recognition and do you use a third-party library? The reason is that we see a lot of problems with available OCR providers. They are either not very robust or the quality was not optimal. And also an own optical character recognition system has some benefits. So for example, it can be adjusted to your specific document type by using, for example, content-specific dictionaries for the post-processing. It might be cheaper in the long run because we have really many document pages which go through our system. And also the whole thing might be better scalable on our own platform. Another benefit can be that it may be trained for special fonts and applications. So, for example, we recently got an application with those kind of numbers, which are called magnetic int characters. So first of all, they include here this special character. And also the numbers, they are readable for a human being, but they look a bit weird. And neither our OCR nor other OCR providers were able to read the special characters or this numbers, so it still did many mistakes. But with our own OCR in place, we had the possibility, first of all, to add those special characters to our codec, and then to retrain the OCR, including those special numbers. And we did this by just creating artificial data and adding it to our training data. Which technology do we use? So normally in optical character recognition, you have like two approaches. One is that you separate each character, you find the boundary of each character and then classify the character. And the second is that you segment the whole text line and then classify the whole text line. We do the latter approach. So our training example consists of an image of a text line and the corresponding text. And this we feed into sequential deep neural networks. And this is like the technology that we use. We use a very simple correction with dictionaries for the post-processing. We also tried more complicated stuff, but it didn't work better. And our OCR also includes a rotation detection if a document has been scanned upside down, for example. And it can also read white on black text, which is a classic example, which is very simple for a human being to read white on black, but it might be a challenge for the machine. So this, for example, how a training example looks like. So we have the image of a text and of a text line and the corresponding text. I think every OCR library needs to have a good post-processing in place because it's sometimes simply not possible to classify by just looking locally. So, for example, if you see this here, it's hard to say whether it's an M or an RN, which is just combined. But if you see the context, it's part of this phrase northeastern state, you can see that it's an RN. And yeah, as I said, we use a simple Levenstein correction, and we also have the possibility that we use content-specific words for doing this, like words which are present in a real estate contract, for example. So how do we perform? We have some test sets where we compare our OCR with other OCR providers for different languages. I just called them here commercial OCR 1 and OCR 2 because one of those commercial OCR providers has strict lawyers which always try to sue you as soon as you publish results with their using their OCR library. And so this is the commercial OCR 2 provider. And as you can see from the comparison, our OCR is comparable to the commercial OCR provider 1 and outperforms commercial OCR provider 2 and Tesseract. Tesseract is like the Google open source OCR, and they somehow use a similar technology as we do. The values here represent the share of words that have been recognized correctly. So, for example, 98.1% means that 98.1% of the words have been found 100% correctly. So as soon as one character is wrong, we say it's a mistake. Also because if one character is wrong, the machine doesn't understand the word anymore. For Chinese, it's a bit different. Chinese is on a character level because they do not really have white spaces between the words. So there's not really like, it's not easy to say where the word starts and ends. I don't have a value here for Tesseract for Chinese. Tesseract can do Chinese, but I didn't have the time to write the evaluation for this character-based evaluation for the Tesseract output. Chinese by itself is very challenging. because they have so many characters. So it might be necessary to use up to 4,000 or 5,000 characters. And first of all, it's easier to confuse the characters, and also from a runtime, it's really challenging if you have that many output classes. So next I want to talk a little bit about layout, which is somehow a step between the optical character recognition and the information extraction. Yeah.
Some of the difference might also have been because you're already using the specific dictionaries, and your test set was more specific on what you're analyzing.
That might be, yeah. Of course, there's a little bit of a benefit. So the test set was also including those special are from our context. So we didn't use them for training, but they are from this context. That's true. The post-processing is typically up to 1% different. So it's not that if you switch off the dictionary, it drops down to 80, below 90%. Concerning the layout, layout detection, a little bit, I would define it like it defines what belongs together and how a human being would read through a document. This is a step between OCR and information extraction. And one typically distinguishes between three different classes, which is structured, semi-structured, and unstructured. Structured is normally the most simple case because you have clear key value pairs associated with each other, which define the information and the corresponding value. Unstructured is like a normal text. Normally the reading order is very simple through the text, but since getting information out of whole phrases, especially if it's within a contract which uses a complex language, this is the most challenging one. And semi-structures are somehow in between. From our application at LEVERTON, we mainly focus on those two things. The benefit is also from the unstructured is it's a higher tolerance of error. So no one expects that you get 100% correct information out of a legal text, while everyone would expect this from a completely structured document. So here I have an example of some maybe semi-structured document where I want to show how challenging layout detection may be. So on this, it's like an artificial shack that I created here, and you have different key value pairs in different dispositions. So sometimes you have like the key, for example, account number and the corresponding account number. So the key is above the value. Sometimes it's left of the value, like the amount here. Here you have also key is left, the value is right, but it's split over two lines. So you would read here first the second line before you jump here. And sometimes you even have some values which don't have any keys, so it's kind of not clear what this is. And human beings are very good at this, combining different kind of information. So because you have here those two dots, you see that you should read on to the right. You also use content information that after the amount you expect a value. Therefore, you will also read from left to right and not like this. So the human being is very good at combining different things. This is not good. Der Beamer? Aber müsste ein sein. Habe ich gerade schon probiert eigentlich? Jackie. Okay, sorry for this interruption. So here's another example, which is like it's like a completely normal text. So this is one of my favorite examples, how bad layouts can be. So here you have like a normal text, but on the left side you have here like a comment written to it, and the comment is so close to the text that you even have not even a white space here between two words which shouldn't belong together. The human being is very good in separating this. So the human being is able to say, okay, this is one part, this is the other part, but human beings do this by combining different things. So first of all, you do this by the layout. So here is some white space which separates this stuff. I don't know if you can see it on the beamer, but this is bold, this is non-bold. Human beings can combine this. Also, temporary shell is not a word, so you know by the content that you should split it here. But machine learning, also deep learning, still is very focused on one specific thing. It's not so good in combining different things yet, so therefore it's very challenging for the machine. And I think a lot of improvement is possible in this whole area of understanding documents, which is very important for the information extraction, but also for robotics and similar things. Okay, let me summarize the OCR before we go to the information extraction. So actually OCR is a very old problem, so already in the 90s systems were available, but I think still improvements are necessary. Machines are still behind human performance. A good OCR is very crucial for each kind of information extraction. Handwritten OCR is something we cannot do, and also in research it's still an area of interest, so it's by far not solved. And understanding layout is also very challenging for the machine and very important for the future of natural language processing. So in the next part, I want to talk a little bit about the information extraction. This can be defined, so I have here the quote of Wikipedia: automatically extract structured information from unstructured or semi-structured machine-readable documents. So at LEVERTON, we do not do general named entity recognition, but we extract data points defined by a specific data model. So we need a predefined data model to define what we want to extract out of the text. Then we want to find the specific location within the document, and afterwards we want to extract maybe additional information which might be parse the number or get the currency, the dates, and so on. So this is the application the user sees. He has here this predefined data model which has a landlord, he has a company number, and we want to find exactly that text snippet within that maybe big document that defines the specific data point. So data modeling is very important for the whole application. So one can say it's like an extraction of a real-world entity. And it's a very important first step to set up this together with the customer to get a common understanding. So for example, here there's an example also taken from the real estate contract called rent charge, which might have several sub-data points, the amount, the period, and the start date. The amount also has, it's like a number that you want to extract also, and the corresponding currency might be dollars or euros. The period might be how often you have to pay this, each year, each month, each week. And the start date is a date which should be parsed then out of the specific text snippet. So we have here an example of a text, and the machine should be found exactly, okay, this is the start date, this is the amount, which has the value $8,134 and this is the period, so for each month. Our machine, abstract view looks like this. Whenever you upload documents to our system, The AI will be triggered. It will try to automatically extract information out of it. This information will be displayed to a reviewer. The reviewers will correct the documents, and afterwards the reviewed documents will be used to retrain the machine. And normally we...
What is the show, will it be showed on computer, or if it goes about AI, the reviewer can change these documents in his head? What is the change?
No, the
Change these documents on the computer?
Yes, yeah. So he can also use this interface to correct the found informations, and yeah. So it's on the computer because it also has to be stored there such that it can be used for retraining. And we normally start to train a specific data point as soon as we have 200 examples available, sometimes also with less. There's one challenge in the whole application, and this is the information might be out of date. So, for example, here you have like an end date that clearly defines that this information is already out of date. But even if there's no end date, you cannot be sure by just looking at one document if the information is still present, because it might be changed by another document. So typically we have like a collection of documents that belongs together. And this is very challenging, also the combination of different documents. And therefore, our workflow looks like this. So whenever you upload new documents, so here those documents represent like documents belonging to one real estate entity. This might be lease amendments, handover protocols. So typically we have maybe like 10 documents belonging to one building, for example. Then the classification will be triggered, which classifies the type. This is a very simple machine learning task, so I won't go into detail here. Afterwards, for each document itself, an information extraction will be applied by just looking locally. So this information extraction step will also extract information that might be out of date, because you just look locally in one of the documents. These we call extract candidates for each data point. And all the documents are then combined in something that we call filtering. And the filtering has the possibility to remove some of the found data points because they might be out of date or overwritten by other documents. So I will go a little bit into detail for those two steps. So how do we work for each document by itself? For each document, we read through the document word by word and put the sequence of words into a sequential neural network. And this tells us for each word yes or no, meaning yes, it belongs to the current data point that we investigate, or no, it doesn't. And by doing this, we get for each document extraction result, which might be out of date, and therefore we have the filtering step that combines now those single extraction results. So, for example, here you might want to find the landlord number, which has been found in several documents, and you want to find which is the crucial one. Therefore, we feed the sequence of the found extracts into a sequential neural network and classify yes or no, which means we keep this annotation or we do not keep it.
What is the value from IoT? To work with this system, you should have an IoT in your room permanent.
This has nothing to do with IoT here. The features that we use here are the probabilities of the found candidates. It's the document type of the document where it is coming from. And probably the most important feature is this time order of the documents, because newer documents can override information from the previous ones.
What is the storage device?
Can we maybe postpone this to the end, because it's not now for this context. So as you see, the information extraction that we tackle is pretty challenging because they're legal text, it's unstructured text. We also have to combine information from different documents. And at the early days at LEVERTON, we of course developed a lot in developing the algorithms. And this was our vision, how we wanted to get better. Over time, we will get more customers, we get more projects, we get more data, and by that we will get a better performance. Well, the first things are true. We got more customers, we got more projects, we got more data. But we also found more data means, we get more inconsistencies, more data model, more bad quality data, different interpretations of the data points by different customers. So this was the challenge we faced. So what we realized is how subjective this machine learning problem actually is. Because depending on the customer or even depending on the project, people might interpret the individual data points differently. They might want to link different things within the text corresponding to one data point. And there's also sometimes a contradiction between what the user wants to annotate and what the machine is able to learn from. And all this increases with more and more customers and more projects. So our pipeline actually looks like this. We have documents from different customers, which will be used to train an AI. And also different reviewers will do different things. And those review documents will be used together in the AI. And there might be inconsistencies. And on the next slides, I want to show a simple example where you can end up with many inconsistencies for the training data. So assume that we want to extract a rand charge of a document. And this rand charge consists of a start date, an end date, and an amount. And it's formulated very easily, like in this table. And for each subdata point, start date, end date, amount is within a column. So maybe customer 1 wants to extract the information like this. So here, 2 subsequent years also have the same rent. So for him, it's okay to combine the two years into one because the amount stays the same. But he's interested in the past data and in the current data. And then we have customer 2. He does not want to get the information from the past rent. He only wants the current and the future rents. Then there might be different reviewers working for customer 1. Reviewer 1 is the lazy one, so he combines the 2 years with the same rent to 1, and it's also a little bit arbitrary which amount he chooses here. And reviewer 2 is the hardworking one, and he marks every year by itself because this is how it is stated here. And in the same fashion, they would do it for the customer 2, just marking the current and the future rent. So as you can see, we got 4 different training examples just by having 2 customers and 2 reviewers. And they are contradictory for the machine because they are the same, but different things are annotated. So some comments. Actually, C and D are more challenging for the machine to learn than A and B because the data points or what has been annotated depends on the day of the review. Also, the machine has to understand the dates and has to realize that this is the past and this is the present and the future. And also, A is a bit more challenging than B because the machine has to understand that this is the same amount. Sounds very simple, but it's also all stuff that the machine has to understand. So what we learned is that the AI is influenced, of course, mainly by our training data. So it only can be as good as the training data. The training data, however, depends on the customer interpretation of the data points, on the reviewers, which make the final extracts that are used for training the AI. And the reviewers also need good definitions and descriptions of the data points such that they can do consistent work. And we also starting now at the beginning, we worked a lot in AI, but now we see how important it is also to look at the bigger view and influence all the other things to get good training data. So first of all, we set up a team of technical consultants who work very close together with the customers, such that they correctly set up data models, such that they correctly use the data points and do not misuse data points. We have clear definitions and descriptions of the data points. First of all, a good naming is important, but also you have to describe what to mark and what is meant by the data points. We also invest a lot in training the reviewers, that they do things consistently, also that they are aware how important data quality is. And we also set up a whole role for this, like a data quality manager, who is responsible of managing the whole process here and having an eye on the quality of the data. This is also very, shows that how important it is for AI not only to look at your algorithm, but also look at the bigger picture. As a last resort, we even set up something that we call data cleansing, which we use if a data point is completely messed up, like customers misused it, it has been misused in the past. So we built up a tool which enables us to quickly clean annotations done in the past for one specific data point. And we found that this really gives a huge jump also in our performance. So what kind of automation do we achieve? So in the area of real estate contracts, we get maybe around 70% automation, which means like 70 is correct and 30% has to be manually corrected by reviewers. Still a lot to do, which the review, still a lot of manual work that has to be done. But it already speeds up the whole process very much, those 70% automation. For easier documents, like maybe invoices or insurance contracts, we get more than 90%. For some applications, also some customers use our pipeline without any review at all because it's close to 100%. So finally the recap of the challenging we have in our machine learning pipeline. First of all, the challenge is that we train actually with a small amount of data. We start with 200 or even less examples. We have a complex document collection structure, so we have to combine information from different documents. We train with data from different sources, from different customers, from different applications. However, we achieved the automation that helps our client and accelerates our customers' workflows. And this is my final slide, and I'm happy to answer questions.